Okay, welcome sa ato ang sample. So we're already on our sample problem number 3, no? So ako lang ni siya i-isolate on this side para explain na to tarong. So we have here a sports car traveling a 30 bank road having a radius of curvature rho equals to 500 feet. If the coefficient of static friction between the tires and the road is mu s equals 0.2, determine the maximum safe speed so no slipping occurs, neglect the size of the car. So again, atong kuha ng maximum safe speed nga dili mo slip ang car. So itong radius sa curve is 500 feet as given here. And then the road is inclined at 30 degrees. So we are asked to determine the speed of the car. So if we ato ni siyang tanaw no in top view, so actually the car is moving in a curve motion, di ba? So or siya pa ngani. So if the car is moving in a curve motion and then this is the row, that is 500 foot. Kani siya. So again, it has two direction of sa motion siyang particle. It has the tangential and then the normal, which is towards the center yang normal acceleration. So this is the normal nga uh, direction. So kung ato na siyang i-represent here, so di ba ato man siyang always ang object ato na siyang gina-represent in as a particle. So from this sample, we know that there is always a normal force acting perpendicular to the surface. So this is the normal force. Let's say that is NC. And then what else do we have here? The car has weight. So acting on the center of gravity. So the weight is equal to the mass times the gravitational acceleration of the car. So take note that this is in imperial units. Therefore, our gravitational acceleration is in imperial units. Since sa top view, this is the normal direction. This is the tangential acceleration. So sa ato pa kani siya nga direction here, this is the normal component or the normal direction. So kung ato na siyang i-draw there, so this is the acceleration goes on that side, normal acceleration. Therefore, this is our normal component. And then what else do we have here? So kani siya, this is the binormal axis. So sa bato na to again, first we draw an FBD of the object or the particle. So sa FBD itong gamiton, the normal and the tangential or the normal and the binormal. So in this scenario, this is a horizontal rotation. So it is best to draw the binormal and the normal axis. So if we draw here, we have the binormal axis and then the normal axis. So naatay normal force like this. So this is N sub C. This is 30 degrees. Okay, 30 degrees man siyang incline. What else do we have? Do we have also the weight of the car? So the weight of the car is just equal to the mass times the gravitational acceleration. And naka-incline siya, diba? So, we have the coefficient of static friction equals to 0.2. So, if you know kung kusog kaayo yung dagan, night time nga pwede ni siya mo saka. It will go up. Or if hinaragid kayong velocity, it will go down. The motion of the car. So therefore, we have two consideration for this one, no? So if the motion goes on that downward, so it goes downward, the friction goes upward. So we denote the friction as small letter f sub s. If the motion goes upward, so the friction goes the other way around. So you need to take note that always the frictional force is always opposite to the motion of the object or the particle. So we analyze this as a particle para mas dali itong kon. So we have two considerations. So if pasaka siya for case 1, then ato ang frictional panaog siya. So let's say this is our Fs. Fs nga panaog for case 1. So that is 30 degrees from the horizontal. And then at kung ato i-consider nga panaog yung motion, slide siya down on this side, then let's say consider this is, or for case 2 nga itong frictional force Fs2 is upward. So this is also 30 degrees. So what else do we have? I think you're already set. So para mas dali atong pag-solve, let's start having a summation of forces along the binormal direction. Summation of force along the binormal acceleration. There is no acceleration, the binormal acceleration. Therefore, this is equal to 0. So forces involved along the binormal acceleration, if you can see. So we'll have two cases, case 1 and then considering also the case 2. So sa case 1, mao ni siya ang si car, the racing car, the sports car, moves upward. And then the case 2, ato lang ko na. So this, in case 1, the car moves upward. And then in case 2, the car moves downward because the frictional force, as I said, is always opposite to the motion of the particle. So if we have two cases here, we have for our case 1. So ang normal component, this is the normal force. So along the binormal, ang designation, we have the NC, so this one, and then cosine 30 degrees. What else? For case 1, we have this one, so this is downward, so minus na siya. Fs1 sine 30 degrees minus the weight, which is equal to mass times the gravitational acceleration, point 2 is equal to 0. So Fs1, we know that the frictional force is just equal to mu, the coefficient of the friction, times the normal force. So atong i-rewrite, we have NC cosine 30 minus 0.2 NC sine 30 degrees minus 32.2 m is equal to 0. Simplifying further, we have NC cosine 30 minus 0.2, just NC sine 30 is, ako ipagawa si m, si mass, is equal to 32.2 m. I-combine ako ning duha, so that is cosine 30 degrees minus 0.2 sine 30 degrees. So on the left side, we have a 0.766025438 and C is equal to 32.2 m. So ito ang m here is just equal to 0.02378960881 and C. This is for our case 1. For our case 2, ang friction is moving upward because the car is sliding down this inclined road. So we have, so same ra gyapon, the binormal component of the normal force is equal to NC cosine 30. And since this moves upward, so this is positive plus Fs1 sine 30, and then minus, same ra gyapon, minus m times 32.2 is equal to 0. So ako yung i-relate na ko tanan, NC, the normal force times cosine 30 plus 0.2 NC sine 30 is, ako lang ipagawas balik si mass, which is equal to 32.2 m. Positive siya because we transposed outside. So simplifying, we have cosine 30 plus ato ning i-add because they have the same variable, NC. So 0.2 sine 30, then okay, so we have 0.966025438 and C is equal to 32.2 m, and we have here our m is equal to what relation with the normal force? 966025438 divided 32.2. that is equal to 0.03. 0.03 NC. This is for our case 2. Okay, so ako lang isulat ang equation no for again for our case 1, atong mass is equal to yung relationship with the normal force is 0.02378960881 and C. And then for our case 2, the mass in its relationship with the normal force is equal to 0.03 times the normal force. So they are almost similar but they give different answer. Okay. So what's next? We have the mass. Here, yes. So atong next mong buhaton, so we first is nag-FB data, then we sum forces along the binormal component. Now we sum forces along the normal component, so which is equal to mass times the normal acceleration, and we know that the normal acceleration is just equal to v squared over the radius of curvature. So summation of forces along n, so atong tan-awon balik ang graph, we have this here. So summation of forces along the n, so ako lang iabay no para di ta malibog. So along the n is kanisya no, kanisya on this side. So that is, so again we have also the case 1 and then the case 2. So for our case 1, we have along n, so na si what? So this is kuan. Let's say that ang acceleration, since ang direction sa acceleration is on that side, let's say that the force on that side is moving on that side is positive. So here we have the normal force here on paingon man dire iyang normal component, so that is positive. So let's say that is NC and then sine 30. What else? For case 1, we have this force Fs1, so positive kay paingon man dadto. We said that kung paingon dadtong force that is positive, so Fs1 and then the normal component that is cosine 30 degrees. What else? I think maura na siya is equal to mv squared over ang radius curvature nato, which is equal to 500 foot. To simplify further this equation, we have nc sine 30. So ato lang ning name no equation 1 and then we have here the equation 2. So we have nc sine 30 plus 0.2 nc cosine 30 is equal to the mass mv squared over 500. Then ato ning i-simplify this side, we have how much? NC, we have sine 30 plus 0.2 cosine 30. This is equal to 0.67320500808 is equal to mv squared over 500. So I want to get rid of this 500. So depending on sa inyo style, but for me, I want to get rid of that. Then we will have an mv squared is equal to 336.6025404. Sorry, I forgot the NC here, the normal force, times the normal force. So let's say this is our equation 2. The equation 3. For our case 2, so sa atong case 2, summation of forces along the normal, sa ato ni siya i-consider. So, ang tanan force pang na to, that is positive again. So, summation of forces along the normal force is equal to the mass times the normal acceleration, which is equal to the mass times the square of the velocity over the radius curvature. We have NC, the normal component of this normal force, which is equal to sine 30 minus na kay paingon naman dadto ang normal component aning sa case 2 nato, minus Fs2. Though ang Fs1 and Fs2, they are just equal but different in direction. Equal in magnitude but different in direction. So muna gibutang nato 1 ug 2 lang to denote that they have different direction. So NC sine 30 minus Fs2. So ang normal component ani that is cosine 30 degrees. So what else do we have? Wala na. So that is just equal to mass times the square of the velocity over 500. So ato itiwas og sulat. So simplifying this, we have sine 30 minus minus 0.2 cosine 30. So, di ba, if you remember, this is 0.2 NC, CFS. So, we have a simplification here. We have 0.32679491192 and C is equal to mv squared over 500. I want to negate this 500, so I want to multiply the equation with 500. Then we will have mv squared is equal to times 500. That is just equal to 163.3974596 times the normal force. Let's say this is the equation 4. So, unsa may bato na to? Take note that ang equation ni case 1 ma-apply lang ni case 1. Ang equation ni case 2 should be applied only to equation 2. So, unsa may bato na to para mag-get na to sa velocity? So, naaman tay mass here which is equal to this relationship. So, this to have relationship para mas dali since ako naman nigi with respect to m ang NC here. So, we can substitute the equation 1 which is this one to here equation 3. So, rewriting again this equation 3, we substitute equation 1 to equation 3. We have 0.02378960881 NC. We have the v squared, right, is equal to 336.6025404 NC. So we divide the whole equation with this value. So we can solve v squared is equal to, we have 336.0625404 divided by this one 0.02378960881. So that is equal to 14,149.14146. So as is NC, so we have NC here, we have NC here, so makancel na sila. Then extract the square root both sides. Then our velocity for case 1 is equal to 118.95 foot per seconds. So what is our velocity for the case 2? We have okay, ato gyapon substitute sa equation 2 with equation 4. So we substitute equation 2 to equation 4. So equation 4 then becomes 0.03 NC times v squared is equal to 163.3974596 NC. So to get rid of this, we divide the whole equation with 0.03 NC. So we have v squared is equal to 163.3974596 divide 0.03, 5,446.581987. So extract the square root. Then we will have a velocity equal to 73.8 foot per seconds. Okay, so sa may pasabot ani sa case 1. So kung nang i-rewrite sa next paper for our case 1, 118.95 foot per seconds. And then for our case 2, that is 73.8 foot per seconds. So sa may pasabot ani. Okay. So if you remember, di ba ang car, that is, we have an inclined road here, 30 degrees inclination from the horizontal surface. So si car, di ba atong case 1, sa may motion ni case 1. So si case 1, atong gi-assume that here, the motion moves upward. This is our case 1. For our case 2, so ako na lang i-separate para mas klaro. So we have 30 degrees here. For our case 2, atong gi-assume nga motion is downward. So this is our case 2. So sa may pasabot aning values. So kaning for our case 1, pasabot ni siya nga at 118.95 foot per seconds. This is just the enough velocity nga igo-igo lang gyud nga kani siya nga object, this car, this particle, will not move upward aning slant na surface. So this is the maximum velocity, just enough for the car not to slide upwards. How about this one? So kani siya, di ba, tong motion is gina-assume na to nga pa down, let's say pa downward siya. So this is just the velocity nga igo-igo lang. So atong V2, which is equal to 73.8 foot per seconds. So this is the minimum velocity, just enough for the car not to slide downwards. So it has yung velocity should be greater than or equal to 73.8 foot per seconds, but less than or equal to 118.95 foot per second para dili siya mo slide downward, dili po siya mo slide upward. So our maximum safe velocity nga dili siya mag-slide is this one.